All right, it's time to talk intermolecular forces. Well, first, what does intermolecular mean? Well, intramolecular forces mean the bonds between the atoms of a molecule. So water is H2O, so the bond between the H and the O in the water. Okay, so intramolecular, we just call them bonds usually. Intermolecular forces are attractive forces that occur between molecules. So this water molecule and this water molecule. What are the attractive forces between them? Intermolecular. Intramolecular is within one H2O. So strong intermolecular forces result in high melting points, high boiling points, typically higher density, higher viscosity, like thicker. The molecules don't slide past each other as easily. So strong intermolecular forces mean the molecules are stuck together more strongly. So higher melting point, higher boiling point. Those are the key ones to remember. So ionic compounds are salts. They have a crystal lattice structure. They have very strong intermolecular forces. So it's a cation and an anion stuck together. So those electrostatic forces hold those ions very tightly together. So those opposite charges are very strongly attracted. So ionic compounds, super high melting points, super high boiling points, very strong intermolecular forces. Metallic bonds also have very strong intermolecular forces. Remember, in metallic bonds, we had those like mobile sea of valence electrons. Because those valence electrons are kind of in a mobile sea, we end up with these positive charges. So again, we have electrostatic forces. We have these positive charges attracting these kind of delocalized sea of electrons. So very similar. So metallic bonds are very strong. So again, things that are metals end up with high melting points and high boiling. Now, van der Waals forces. Okay, so that's kind of the next category. It's a general term to define attraction of intermolecular forces between molecules in covalent compounds. So we talked about ionic, we talked about metallic. Now we need to get into covalent. So there's a broad umbrella term called van der Waals forces. There are three types of van der Waals forces. We have dipole-dipole, hydrogen bonding, and London dispersion forces. All right, so London dispersion forces first. That's in all molecules. So all covalent compounds, they all have London dispersion. But it is the only intermolecular force that's in non-polar covalent, so very weak. All right, so London dispersion are the weakest van der Waals forces, and they're the only ones in non-polar covalent. Even though polar covalent also have them, they're the only ones. What happens is that as there's a temporary shift in the movement of the electrons, so there's a temporary positive and negative that attract each other. So London dispersion forces, super weak, non-polar covalent only have these, right? So what about polar covalent? What do they have? Well, they have dipole-dipole forces. Remember, the electrons are pulled more strongly to one side, so we have these partial negatives and these partial positives. Well, dipole-dipole forces are those attractions between the partial positive and the partial negative. And it is much stronger than the London dispersion forces, but still relatively weak. Okay? But there's a special one, and that is hydrogen bonding. It is the special type of van der Waals, special type of intermolecular force that is strong, and it gives water its unique properties. So water has a high melting point, unusual for a covalent compound. Okay, so where do we get hydrogen bonding? Well, hydrogen, obviously, but it is with one of three elements, with nitrogen, with oxygen, and with fluorine. So they're in a little row like that, NOF. So if hydrogen bonds with nitrogen, hydrogen bonds with oxygen or hydrogen bonds with fluorine, then we can end up with hydrogen bonding, because the hydrogen from this molecule forms a hydrogen bond with the oxygen in this molecule. The hydrogen in this molecule forms a hydrogen bond with the oxygen in this molecule. So hydrogen bonding, very strong. They love to ask questions about hydrogen bonding. So again, here is the intramolecular force. That is the bond within water itself. Intermolecular force is between water molecules. And this is a hydrogen bond, a special kind of van der Waals, special kind of dipole-dipole force. So if we summarize it, if we have ions, okay, then, so say we had salt dissolved in water, that's this. We can have an attraction between an ion and a dipole, so between a positive ion and a negative partial charge, okay? If there's only ions, then we just have ionic bonding. If there are polar molecules, we have London. If we have polar molecules, we can have dipole, dipole, and hydrogen bonding. If we don't have polar molecules, that means nonpolar, then we only have those London dispersion forces. And all three of these together are forms of van der Waals forces. And there you have it. That's intermolecular forces. I hope you learned something new today.